This is an example of a radical expression that we'll use throughout this chapter. It's just an expression that's underneath the radical sign. And so our radicand, instead of just being a number or just one variable or something like that, it's a whole expression here. And what they'll do with these problems is then they'll go through and they'll tell you like a equals 7, b equals 8, c equals 1. And they'll give you the information. And so really what you're going to end up doing is you're treating the radical sign almost like parentheses, where you need to simplify everything inside of here first, then evaluate the radical sign. And so I want to go through b squared, so that's going to be 8 squared minus 4 times a, which we now know is 7, and then we're multiplying that right away, times c, which we now know is 1. Now 8 squared, 8 times 8, that's 64. Remember, we've got to do our exponents first. We're subtracting 28. Now you go through and do the math. 64 minus 28, you're going to get 36. The square root of 36, and remember they gave us this, so they're asking for the positive root here. Unless the directions say give all roots, they're asking for the positive root, and so I can just give my answer. The square root of 36 is 6. And so if they give it to you like this, remember that they're asking for the positive root. The only way I'd have to give that this is plus or minus 6 would be if in the directions it said give all roots. Let's now look at the fallen object model. The fallen object model relates to when something is dropped or something is falling through the air there. And so if we were going to go to the top of the school building here and drop a container off the top, many people in science will do egg drops, where they drop a carton with eggs in it off the building to see if they can keep it from breaking there. That'd be an example of when you might use this to see how long it would take to hit the ground, or to see what height it would be at after a second or two. The h in the formula here, so the formula h equals negative 16 t squared plus s. The h in the formula is the height after t seconds, and so it's how high the falling object is after so many seconds. The negative 16 is always going to be there. Now that's the force of gravity, and it's the force of gravity in feet per second. It's actually feet per second squared. A little typo there. That's feet per second squared. The t is the time in seconds, and the s is standing for our initial height. Now the initial height is going to be in feet, and the height here is also going to be in feet. The time doesn't need to be in seconds. And so make sure you are taking a glance at those labels as you look through there. And so let's go ahead, let's just rewrite it over here real quick and see a problem. Let's say I am going to drop something off the school. Our school's 2 stories and stuff. Let's just say the school is about 32 feet tall there. And so we got a person up here that's going to drop something off, and when they drop it, they're going to drop it off, and it's going to fall pretty well straight down there, and it's going to hit the ground. And hopefully, if it's the egg situation, that it will not break. Hopefully, maybe we should drop bacon off there, drop a pound of bacon off there, and see how long it takes the bacon to get to the ground there. Maybe this is like a giant frying pan that we're going to drop the bacon onto and fry up some bacon. That would be delicious. The 2 heights here. We got the height here and the s here. We got to make sure we understand the s is going to be our initial height there. And so the s here is going to be 32. The negative 16 is always going to be there. What they would say in this problem is they'd say something like, how long is it going to take the bacon to reach the huge frying pan that's on the ground? And since they're asking how long it's going to be, we're going to put the t in there as our variable. That's what we're looking for. We're looking for t. So we're still missing the h here. Notice the h is actually the ground here. So we got to look at it. We're dropping it from 32 feet above the ground. Now the equation has no concept of the ground stopping the bacon. So for the equation thinks that the bacon is going to keep on going forever. But that's not what actually happens in real life. In real life, it stops by the ground. What we got to make sure we understand then is we got to put down where the ground is. The ground is actually at 0. So the ground's at 0. If I was going to look at a point down here, that point would end up being negative. So anywhere down here would end up being negative. I want to know how long it takes it to get to 0, because when I measured the 32, I started at 0 here at the ground, and I went up 32 feet. And so I have 0 equals negative 16t squared plus 32. As we just talked about in the example before, I'm going to take away the 32, because I want to get that t squared all by itself. So I'm going to divide by negative 16, divide by negative 16, and I get 2 equals t squared. Now I don't want to know what t squared is, I want to know what t is. So I have to take the square root of both sides. Technically this should be plus or minus the square root of 2. But as I start looking at this is a real life problem. It doesn't make sense to have negative time. And so as I display my answer, t is equal to the square root of 2, the positive root, and that is approximately, we can use that squiggly equal sign to show it, that is approximately 1.41 seconds. And so that is the falling object model. Okay, and to end it here, we'll end with a few jokes here. This first one is actually from a student in my 5th period class. He said, "What did 0 say to 8? He said, "Nice belt." What time do you guys go to the dentist? I know what time I go. I go at 2:30. Have a good day.